Hey kids, it is your mentor, your hero, Mr. Cozy, and this is video 12. Video 12, we are going to talk about interval notation, what problem it solves, how it's structured, and talk about some vocabulary. The idea behind interval notations is that there are frequently questions in math that we can't answer with a single number. An example of such a question is, what could I put in for x here? What are all of the valid values for x in this expression? Another way of phrasing that is, what is the domain of this function? Okay? Because I can't take a square root of a negative number, not any value for x will work. For instance, x can't be 1 because that would give me negative 3 under the radical. Okay? But there's more than one x that would work. A 5 would work, a 6 would work, a 7 would work, 8.2 would work, 9.324 would work. A lot of numbers will work, so how can I refer to them collectively? Okay? Just looking at this, we can see if you think about it, that x must be at least 4 for this to work. Or to put it another way, x has to be greater than or equal to 4. Okay? And typically when you were asked questions like this in the past, you would answer them one of these two ways, either with a sentence or with an inequality. I'm going to show you another way that is an interval, and it's a really slick method. So, I'm just going to write down some examples of intervals, and we can talk about what this means. Okay? So, this interval consists of every number from 3 to 8. Okay? So, this consists of every number from 1 to 5. This consists of every number from -4 to 6. What do you think this interval consists of? Every number from -8 to 7. So, every interval consists of two numbers separated with a comma. The number on the left is our low number, or our lower bound, and the number on the right is our high number, or our upper bound. Okay? So every number from 3 to 8 is included in this interval. That's 4, that's 5, that's 6, that's 7, but that's also the decimals. 5.2, 5.3, 5.33, 5.333, 5.333333301. All of those are included in this interval. So every single one of these intervals, no matter how small it is, contains an infinite number of numbers, because there's an infinite number of decimals that we can write between any two numbers. Okay? Now, what's the business with these brackets and parentheses? If a bound has a bracket in front of it or after it, that means that the bound is included in the interval. So not only does this interval contain 4, 5, 6, and so on, it also contains 3 and 8. It contains the lower and upper bound. Okay? Over here, this interval contains -4, as well as all of the numbers after it up to 6. This interval contains 7, and all of the numbers less than 7 up to -8. Okay? So if there's a bracket, that number is included in the interval. If it's a parenthesis, it's not included. So this interval consists of every number from -4 up to but not including 6. This contains not -8, but it contains the numbers that are right after it, and then everything else up to 7 and including 7. This interval contains neither the 1 or the 5. However, it contains everything in between. So 1.00001 and 4.99998, those are included, yet the 1 and the 5 are not. So to summarize, every interval consists of two numbers. It's a low number and a high number. And then if it's included, if the low number or high number is included, we use brackets around those numbers. Otherwise, we use parenthesis. Okay? So when you are writing an interval, ask yourself, what's my low number? What's my high number? And then are they included? Okay? A little bit of vocab. If neither the low nor the high numbers are included, this is called an open interval. If the low and the high is included, it is called a closed interval. And if one is included and not the other, that's called a half open interval. Okay, and that's just some vocab to throw around. Now, let's come back to this previous example. X has to be at least a 4. So what's my low number here? What's the lowest number X can be? And that would be 4. Okay? Is the 4 included? Could X actually be 4? Yes, so I use a bracket. What about your high number? Here's the thing. There is no high number. This goes on forever. This is called an unbounded interval because it's missing an upper or lower bound. If you're missing an upper bound, you use infinity. And this says that I start at 4 and then I go all the way up forever. Okay? Now I use infinity if it's a high number. I always use parenthesis when I use infinity. Okay? Now, if my number happens to be missing a lower bound, I use infinity, but because it's a lower bound, I call it negative infinity. And once again, I use a parenthesis. So this interval would be every number up to, but not including the 5. All right, so this is just structures of intervals. We'll talk a little more about it tomorrow and do some practice. I'm good for now, so have a great day. Bye.